Hello all. So today we are going to cover a very interesting topic. As you can see, Kubernetes into ours, and this is version 2.0. So without a further ado, I will be getting started. So as you can see on your screen, so these are the things which we are going to cover. So in the very first section, we will have introduction to the Kubernetes. What is Kubernetes? So we will be looking at that. The second topic, I will be letting you know how you can basically create a minikube like environment using Ubuntu machine. So let's talk about Kubernetes platform or about the Kubernetes host platform. Okay, so let's talk about the Kubernetes host platform. Okay, so Kubernetes as a platform is available on, the first one is it's available on public cloud. So it's also available in on-premise. Okay, and then third is nothing but the minikube. So minikube is also is an example of single node Kubernetes cluster environment. Okay, So when we are talking about public cloud, we will be looking at certain examples. So for the time being, EKS, if you are familiar with the AKS, GKE, so these are all the Kubernetes distribution that are being offered on public cloud platforms by multiple cloud service providers. Okay. So let's do that. So before I go to the next slide, there are certain other things which I would like to mention. So who basically governs Kubernetes platforms? Who basically governs Kubernetes platform? So the governing body which is responsible for governing Kubernetes platform, we call it as CNCF. So CNCF is nothing but the Cloud Native Computing Foundation. So Google donated the project which is known as BOG technology to the one particular foundation, which is nothing but the Cloud Native Computing Foundation. So now CNCF owns the right on the Kubernetes distribution. Okay, just remember that. So now before we move on, let's look at some other stuff, and I will be going to the next slide. So we talk about Kubernetes and the ecosystem, right? So Kubernetes is something which basically provides you the core functionality, right? So Kubernetes is something which basically provides the core functionality in which you basically run containers, right? So container is nothing but which provides you the runtime environment along with all the application dependencies. So this is what we call it as core functionality. But when we talk about the entire ecosystem, now you can look at the diagram itself. So for example, in the Kubernetes distribution, you also talk about all the other supplementary functionalities which basically makes the entire Kubernetes distribution. Okay, so for example, the load balancer, right? So when the application is being accessed by the external world users, you need load balancers in front of your application so that it can become available for the users to access, which might be from the external world, right? So load balancer is one of the example. Secondly, the network plugins, all the network plugins that are being developed by all the third-party providers which are available so that you can integrate with your Kubernetes distribution. Then you talk about storage, right? So in the storage, you have so for example, we will talk about many of the Kubernetes distribution. So for example, the word persistent volume, that will basically give lot of choices. For example, you can basically make use of EBS elastic block volumes or elastic block storage volumes, which is being offered by the AWS. You can also look at Azure related disk. So we will talk about that in some time. But all these storages you can integrate with your Kubernetes distribution or Kubernetes platform. Okay, so you talk about observability, right? So observability, there are a variety of the services which you might want to integrate with your Kubernetes functionality. So for example, Prometheus. Then you talk about service mesh. So if you have heard about Istio as a platform, which basically gives you an opportunity and which basically provides the functionality of the service mesh. Then you talk about the logging mechanism. So there are various logging mechanisms, or there are various logging functionalities provided by the third-party providers. So all these functionalities can be supplemented to the core functionality, and that makes the entire Kubernetes and the ecosystem. Okay. So let me clear my screen. And I would like to talk about some of the examples now. So for example, as I mentioned, so Kubernetes distribution are available on premises and it is also available on public cloud. So let's talk about the examples of the public cloud distributions, which is nothing but the EKS. So that is nothing but the Elastic Kubernetes Services. That is one of the offering by the AWS. Then talk about the AKS, Azure Kubernetes Service. So that is provided by the Microsoft Azure platform, right? And then you have heard about the GKE. So GKE is nothing but the one particular platform that is offered by the GCP, right? So Google Kubernetes Engine. So these are the Kubernetes distribution themselves, right? So for example, if you talk about EKS, you have an opportunity to integrate with the various other services. For example, if you talk about storage, yes. So the default storage you can think of is EBS volumes, right? So like that. So this is just an example. And so let's talk about on-prem as well. So for on-prem, you must have heard about some of the Kubernetes distribution examples. So for example, Rancher is one of them. So if you really wanted to deploy your Kubernetes on your data center itself, so Rancher is one of them. Then OpenShift is one of the offering that is offered by the Red Hat, OpenShift. And the third one, I would say Enthos, right? So Enthos is also one of the Kubernetes distribution services that is being offered on your on-premises platform by the Google, right? So these are certain examples. So now we are at a place where we really would like to explore certain things like how to create a minikube like environment, right? So in this particular juncture, we will create a minikube environment. So what is minikube? Minikube is nothing but the single node. Minikube is nothing but the single node Kubernetes cluster. Okay, single node Kubernetes cluster. So we will look into that. So without a further ado, what I will do is I will just be SSHing into my machine. So just give me a second so that I will just get an IP address of my system and we will go from there. So what is the IP? So let me, so before I do that, so this is my YouTube channel. And if you subscribe to this particular channel, you might be knowing that I have multiple videos. So for example, so you can see that I have one particular video, minikube cluster in 2 minutes. And similarly, if I scroll down, I have one more video. So for example, if you can see here, practical Kubernetes in 2 hours lab setup. So where I am basically explaining or basically sharing how does my environment look like. So I am basically making the use of the AWS EC2 instance, and I have Ubuntu as an operating system, and then I'm allocating certain amount of the memory and certain amount of the CPUs to my machine and trying to install a minikube, and there are certain dependencies I'm trying to install like kubectl. Okay, so these are some of the videos which might be helpful as well, but anyways, I'm going to demonstrate that in this particular session as well. So this is my slides. So without a further ado, let me move on to my okay, so let me start a new session. So the IP address which is getting allocated to myself or my machine is 212. Specifying my private key. Yes, so I have access to my Kubernetes environment. So let me close this window. Okay. So if I say host name, and let me make it a little bigger. So now what I'm going to do is, so for example, if I go to so this is my GitHub public repository, and I'm basically looking at Kubernetes as my repository, and I have gotten into one particular script which I have kept here in Kubernetes repository. So what I'm going to do here is I will copy the entire script. I will say minikube.sh. I will go into the insert mode. Just a second, I messed it up. Sorry about that. Not sure what is happening. Let's call it as minikube. Okay, so I will go into the insert mode. I will just paste the entire script here. That's it. I will go into the escape mode. That's it. So now I will just be changing permission for my script. So I will say execute permission minikube. That's it. Now I should be able to run this particular script. So let's run that. Now you can see that once this particular script is getting executed, my Kubernetes or minikube single Kubernetes environment will be ready. So it might take some time. So by the way, I do have another machine which has already gotten minikube configured. So we can utilize that environment as well. So before I go into that, just make sure that you understand the minimal requirement for your minikube cluster. So as you understand that, for me, I'm basically using the version 22 for Ubuntu image, and for my machine, I am basically using 16 GB RAM, and I have 40 GB disk space allocated. So once my minikube cluster is ready, I will be allocating 2 virtual CPUs, and I will also be allocating 8 GB of RAM. So this is how my environment will look like. So let me try to check whether it is ready by now or not. So it is asking me the input. So let me clear my screen. So this particular script basically asks you to press enter. So only I think one input needs to be entered and your environment will be ready. So what we can do till the time is, so first of all, we are going to discuss about kubectl utility, so which will basically allow you to manage your Kubernetes cluster remotely. So that is one of the thing. And let me go back. I think it might take little more time. So what I can do is I can go back to my second machine, which I already have. So yes, my environment is ready now, so I can use this environment. That's not a problem. So let me clear my screen. If I say minikube status, you can see it is not found. So the first thing I will do is minikube. I will say start. And if I go to my GitHub repository, you can see that it has given me a message as well. So I can basically assign Docker as an virtual machine driver. And similarly, I will also assign memory. So I will call it as 8192. And similarly, CPUs, I will assign 2 virtual CPUs. So as you can see that it is basically downloading the Kubernetes image. So our environment will be ready in some time, so that's not a problem. So if I really switch my tab and if I go here, so this is how it looks like. So for example, if I say minikube, you can see that my minikube environment is ready. It's already configured, and I'm trying to configure the environment here as well. So in another 30 seconds, our environment will be ready. Meanwhile, we can start with our demo, so that's not a problem. So what I can do here is, if I say kubectl, I will say completion -h, and I will pipe it to less. So what it is basically giving me is I should be able to make a use of tab completion as a functionality. Okay, so if I do that, so here you can see that installing bash completion on macOS using homebrew. So let me go a little down. So now you can see that I have got installation or bash completion for Linux as well, and I am interested in this utility. What I can do is, this is what I am looking at, and I am interested in this functionality. If you see this particular thing, source, I'm going to use that. Let me escape this. So I'm going to paste here. So if I do that, I will be able to make a use of tab completion. So I will make a use of this particular command in my machine, which should be ready in some time. If I go to my slide, so the first thing which I have mentioned is I think it is very easy. So for your convenience basis also, you can use this particular command kubectl completion -h, and I am going to make use of this particular command or tab completion in my rest of the demonstration as well. So meanwhile our environment is getting ready, let's talk about the Kubernetes resources for some time. So just a second. So we are going to talk about all these resources which you are able to see in your screen as of now, right? So just a second. So let me, okay. So pod is nothing but the basic unit, or I will say the basic entity that basically represents one or more containers. But normally pod should be having only one containers, right? So normally pod can have sidecar containers, ambassador containers. So we can look at some of the use cases, but most popular arrangement is one pod, one container, right? So Kubernetes is responsible for managing pods. So Kubernetes does not manage containers, it basically manages pods, okay? So pods is one of the basic entity or one of the basic resource which we will be using in most of the cases. Now what is the deployment? So deployment is nothing but, I would say, so any application which will be getting deployed in Kubernetes, we will be making the use of deployments, right? So deployment is something. So if I configure one attribute which is nothing but replicas, so which says I have configured or I have given a command so that this particular deployment will be creating 3 pods under that deployment, right? So it will have 3 pods, P1, P2 and P3, right? So let's say if my P3 pod goes down, I will instantly have one more pod which is P4, which will be getting up at the same time, right? So at one particular point in time, my deployment will always have 3 pods running simultaneously. So that is the important concept. So even any particular pod terminates or crashes, I will be having that those particular pods which are crashed will be immediately replaced by newer pods. So that is important, right? So in every time we never use pods in a standalone pods in a standalone arrangement, right? So just understand that for all application we basically make a use of deployments, okay? So what is config maps? Config maps are something which is responsible for storing site specific information, right? So for example, you might be having config files for your applications. So you can basically store your config files in config maps, right? So any site specific information can be stored with the help of config maps. So always remember, pods always have containers, and containers are ephemeral in nature, right? Ephemeral in nature. So pods are ephemeral in nature, containers are ephemeral in nature. So therefore the drives which are mounted to these containers, they are also ephemeral in nature, right? So if I really wanted to store anything which I stored on my container on the persistent basis so that it will not be getting deleted once the containers or pods are getting replaced, I can basically make use of persistent volume as a storage class. So this is nothing but the storage class, okay? So I think we are good for the time being. Now we can get started with our demo. If I go to my machine, you can see that now if I try to clear my screen, if I say minikube status, now you can see my control plane is up and running. So what I am going to do is, I've already demonstrated. So this is the command which I'm going to use for the tab completion, okay? So kubectl get pods. If I say get pods, you can see as of now there are no resources found in the default namespace. So before I get started, we are anyways talking about all the resources. So let's also get started with the namespace, okay? So we discussed a little bit about the basic resources. So one more thing I really wanted to demonstrate. I will say kubectl API resources. Let me make my screen little smaller. So I have made my screen little smaller for the purpose. So now what you can see in the API version is a V1. So these are the basic resources that are offered by the Kubernetes environment. So you can see that namespace, limit ranges, endpoints, config maps. So all these resources are available in your Kubernetes distribution, persistent volumes, pods, right? And you can also see these are the shortcuts. So for example, for the config maps, I can use CM. For the namespace, I can use NS, okay? So these are the shortcuts available, and similarly if I scroll little down, so you can see the V1 version basically offers all the basic Kubernetes resources. At the same time, some of the resources which might be very important for the Kubernetes distribution, you can see in the apps V1 as well, right here. So in the apps V1, you can see the daemon sets, you can see the deployments, you can see the replica sets, you can also see the stateful sets, okay? So for the time being, just remember these are some of the resources and you can list those resources. You can also see their short names as well. So let me make my screen little bigger and I can clear my screen. So let's start with our demo. So the first thing I'm going to do is kubectl. I am going to create a deployment, and the name of the deployment I will say nginx, okay? I will be making the use of the image which is nginx, okay? And minus replicas is equal to 3, okay? So I've created a deployment, kubectl get all. Okay, so you can see that there is a typo in my command. So in the image I try to I have done the typo, and therefore you can also see that status error image pull, right? So what I can do is kubectl delete deployment and I will say nginx. My deployment is deleted. Let me clear my screen. So here I just need to make sure that I am basically pulling the right image from my Docker Hub repository, nginx. So if I say kubectl get all, I'm trying to list all the resources which might be corresponding to the deployment which we have created, right? So you can see here you can see the pods, right? So these are the pods. So I mentioned replicas is equal to 3, therefore this particular deployment has 3 pods, okay? And you can see the status container creating, okay? At the same time, you can also see by default there is one particular service which is nothing but the Kubernetes. So this is nothing but the default service. We will talk about the service in some time. And this is nothing but the replica set. So replica set is responsible for how many pods will be running in my deployment, right? If I do not mention anything, by default it will say only one pod will be running, right? One pod. If I do not say replicas is equal to 3, only one pod will be getting created as a part of deployment, okay? So let me try to clear this screen, and if I run this particular command once again, now you can see the status of my pods, which is nothing but the running, right? You can see that these particular pods are running from 64 seconds, okay? So let me try to clear my screen. Now the second thing is kubectl get pods. So similarly, I tried to retrieve all the resources for the deployment. So I can also retrieve the details for only pods, right? So this is how I am going to do that. If I try to describe, let's try to describe one of the pod. I will say describe. I will say pod. I am using auto tab completion. So any pod, right? So this is the pod. If I try to describe my pod, let's see some of the details corresponding to this particular pod, okay? So I will be going bottom up. So in the last, you can see there are certain events. So these are certain events, you can see what has happened. So for example, you can see that successfully assigned a default nginx to the minikube. So we have successfully pulled the image from the Docker Hub. If we do not specify, Docker Hub is where our images will be getting pulled. Now you can see that container is created. Now you can see the container is started. So these are all the logs or all the events corresponding to this pod. Okay. If I scroll up, there are certain important things which we can highlight. The first thing is, this is nothing but the name of the pod, right? Now you can see the namespace, which is nothing but default. If I do not explicitly mention the namespace, all the resources will be getting created in the default namespace. Okay. Now you can also see the details of the node. So my node is nothing but my minikube, and I am basically running minikube, which is nothing but the single node Kubernetes cluster. So all the pods which I will be creating will be getting allocated to my single node, which is nothing but minikube. We can also make a use of labels in our queries. Okay, so we will make a use of these labels as well. So this is important. Now you can also see that this is the IP address which is getting allocated to our pod. Okay, 0.7. So this is the IP address of the pod. Okay. At the same time, if I scroll down and some other stuff which might be important, so you can also see the container ID, and you can see that this particular image is pulled from the Docker Hub as a repository. You can also see the latest status of the pod which is running, right? So these are some of the important things, and if I scroll down, so I think these are the things I really wanted to show. So now we can move forward. So what I'm saying is, if I say kubectl, so let's create one more deployment, create deployment, and I will say nginx1, and this time again I will be making the use of the image is equal to nginx. So this time I will not be mentioning replicas is equal to 3, right? So it will by default create one particular pod. Now you can see, so kubectl, I will say get pods. So now you can see there are 4 pods, right? So for example, the 3 pods which are these 3 pods basically are a part of the deployment, which is nothing but the nginx, and the last pod which I have created, it's a part of the deployment nginx1. Okay. So what I can do now is we can basically make the use of the labels, and let's see that how it works. I will say kubectl, I will say get pods, and I will say select. I will basically use selector label, selector, and I will say app is equal to nginx1. So only one particular pod will be getting listed because I am basically making the use of the labels which are getting assigned to each deployment or each pod. Okay, so this is how you can also list services or all the resources corresponding to one particular deployment, one particular pod, by effectively using the labels. Okay, so let's move on. So before I go further, I would also like to give you an example of the declarative way, how we can basically use declarative way, right? Before moving on, so here only let's see that. So one is nothing but the imperative way, right? Imperative way. So when I create a deployment, I basically created a deployment with the use of this command, which is kubectl, and I ran this particular command. And when I create this deployment with the help of kubectl as a command, it basically means I am basically using imperative way, right? So I am basically running certain commands or certain shell commands to create or destroy resources. When I use certain commands to create and destroy resources, it basically known as imperative way, right? And I can also create and destroy resources with the help of YAML files by referring to the YAML files. Okay, YAML files. When I am basically making the use of YAML files, we call it as a declarative way. So most of the times we are basically using declarative way. We will be making certain changes to the YAML files, and we will be committing those changes with the help of our Git, right? And so that is the DevOps way of doing, or DevOps way of managing Kubernetes as a platform, right? So let's try to look how basically we can make a use of declarative way of managing Kubernetes cluster, right? So let me try to, so before I do that, kubectl get pods. Now you can see that there are 4 pods running in my environment. So if I try to do ls, you can see that there is nothing much. So if I say kubectl and I will try to create one more deployment, create deployment. The name is nginx2, okay, and I will be using image is equal to nginx2, okay. Image is nginx, and I will also be using one more parameter, dry run is equal to client. So that's it. And what I'm going to do, I am basically outputting a YAML format, okay, and I will be directing to one particular file. I will say my deploy.yaml. If I do that, when I'm basically making the use of this particular parameter, which is nothing but dry run, it is not going to create any deployment or any pod for that matter, right? It is not going to create any resources, no resources. It is not going to create any resource, right? So it is just going to output one particular it is just going to output into the file which we are using, my deploy.yaml. So let's try to look around in that particular file. So if I try to less my deploy.yaml, this is how does the file look like. So kind is nothing but deployment, right? In the kind, it can be your pod, it can be your deployment, it can be your volume. So it basically represents the type of the resource which you will be using or which will be managed by Kubernetes, okay? Then you can also see that we have given the name of the deployment as an nginx. So what is the name of our deployment? The same name will be getting to the labels, right? And I have not mentioned replicas as an attribute or parameter. So by default, it will make one particular pod as a part of deployment. And you can also see here in the specs is very, very important. And in the specs, you can see the containers and the image. We are using the image nginx, which will be pulled from Docker Hub repository. So this is how our YAML file looks like for the deployment, right? So of course, we are not basically making the use of a lot of features under deployment, but this is how the file looks like. So what I can do is now, since this particular file can be managed by your Git repository, always remember this particular thing. So this YAML file I can easily commit to my Git right? And I can also upload to my GitHub or GitHub or GitLab repo, okay, where I am basically keeping all the code, right? So once this particular file, we can make any changes. We can also make changes with the help of the Git as well, right? So this is how mostly we will be using a declarative way where we will be making changes to the YAML file, okay? So if I say kubectl and I will basically say apply, I will say -f and my deploy.yaml. So when I say that, if I enter this particular command, one more deployment will be getting created. So kubectl. So now you can see that these are the 3 deployments as of now. So you can see that this is the deployment which we have created with the help of declarative way, right? Declarative way, which is basically making changes into the YAML file. Just remember that declarative way, we basically manage YAML files. We make changes to this particular file and committing those particular files to our Git or Git repo. And this is how we are basically managing Kubernetes configurations, okay? So let's move on. So before I move on, there is one more resource which we would like to discuss, kubectl. I would say get and I will say ns. Ns is a shortcut responsible for namespaces. So if I do not specify namespace, all the resources will be creating in the default namespace, right? So most of the developers will be creating resources in the default namespace unless specified. So now you can see here that there are 3 other namespaces: kube node lease, kube public, and kube system, right? So these are the namespaces which are responsible for running some of the workloads in your master node, right? Some of the workloads in the master node. So your Kubernetes, your minikube cluster is also running some of the components in your master node. So let's see that. So there are certain pods which are running in your kube system namespace, which is responsible for, which are running in your master node, right? So if I say kubectl, I will say get pods, I will say -n, or better, I can make a use of namespace and I will say kube system. So now you can see that there are 6 pods running, 6 or 7 pods running, and they are basically performing some of the basic functionalities which might be needed in your Kubernetes platform, right? So you can see that there are 7 pods running as a part of your kube system namespace, and these particular pods are basically performing some of the functionalities being managed by your master node. Okay, so we will not discuss about that, but so namespace is basically used to segregate your resources, right? Segregate, or I would say segregate, or I would say isolate your resources. So if you group your resources by different namespace, it is equivalent of creating your resources in the different data centers actually, right? This is how you can isolate your resources, by creating different namespaces, okay? And there will be no communication between the resources at all. Okay, so let's kubectl. There are a lot of pods running, I know. So you can see that there are 5 pods running. So let's try to do one more thing. Let me go back to my slide. So now we have completed some of the things, right? So I think we have basically forged an understanding. We have got the introduction of the Kubernetes. We also looked at how we basically stood up your minikube environment. Now we also discussed about kubectl, how we can manage Kubernetes resources remotely. Then we have talked about in detail what is the difference between the pods and deployments. So now we are at the juncture where we will be discussing about how to troubleshoot applications. So now all these particular things in which we have a practical demo. Okay, so let's go ahead with our practical demonstrations. So stay tuned with me. I have got a lot of resources to share with you in this particular session. So we are here in troubleshooting applications. We already looked at pods and deployments. Now we are basically look at how we can troubleshoot our applications. Okay, so let me go back to my screen. Let me clear my screen. kubectl, I would say delete deployments, and I will say nginx, say nginx1, I will say nginx2. Okay, so we have successfully deleted all the deployments. If I try to list kubectl, now you can see that there are no resources found in the default namespace. Okay. So now what I'm going to do is, let's create a deployment. And this time I'm using a name. MyDB is the name of my deployment, and I am going to use the image, which is nothing but MariaDB. So this particular image is not kept locally in my system, so this will be getting pulled from Docker Hub as a repository. Okay, and I will also be giving replicas is equal to 3. So there are 3 pods in our deployment. So So now you can see that our container is creating basically. Now you can see that we have received an error, right? So before I go further, so now you can see the status, right? So there are 3 pods. Now you can see also that 0 out of 1 pod is ready. 0 out of 1 container is ready. 0 out of 1 container is ready. And you can see the container is getting created here. But here you can see that we have got some error in terms of, so these particular containers are not ready in our pods, okay? So how we can troubleshoot that particular thing, right? So the first thing I am going to do is kubectl describe, I will say pod. I can basically take any particular pod for that matter. I'm basically making the use of tab completion. So any pod, so let's say the 3rd pod, okay, it will not, so this is the pod. I'm trying to describe all the details corresponding to this pod. If I press enter, now you can see that these are the details I have got. I will be moving little further. Let's try to see. So the first thing is, this is the name of the pod. You can see that this is the namespace in which the pod is getting created. This is the node. We are basically into the single node Kubernetes cluster. Therefore, all the pods will be getting created in the in this node, which is nothing but the minikube. Okay. And you can also see the IP address getting allocated to this particular pod. Okay. If I go a little bit down, so here we are able to see some of the important things, right? We are basically seeing, okay, this particular image is getting pulled from a Docker Hub as a repository. The state is nothing but waiting. The reason is crash loop back off. And you can see that the last state is nothing but the terminated, right? If I go further down, what we are able to see. So there are certain events. Let's try to look at certain events. Now you can see that the image is successfully pulled. This particular image is successfully pulled from the Docker Hub repository. And here the image is getting pulled. Now you can see that it has already created a container MariaDB. It is trying to start the container MariaDB. And then in the last, you can always see the warning, which is nothing but the back off, restarting failed container MariaDB in this one. So you are able to see some of the events corresponding to this particular pod, and I already know the last status of the pod is terminated, right? So if I try to clear my screen, if I say again, so now you can see that we are basically getting error, right? So the last state of the pods are getting like this, okay? The crash loop back off. So I do not know what this particular status mean, right? I do not know what this particular status is meant. So let's try to, so now you can see, okay, so Kubernetes is at the backend is basically trying to restart the pod time and again. Okay, if one particular pod is getting crashed, it is trying to create a one more pod as a replacement. But anyways, you can see that these particular pods are not getting started as of now, right? It's not able to run at this point in time. So the second thing I'm going to do here is, we have already described our pod. Now the second thing I'm going to do is I will say logs my db. Okay, and let's look at again the same pod which we have already tried to describe. If I see that I'm getting some of the hints, right? So entry point script, so that is not important. Switching to a dedicated user MySQL, okay, so that is custom built in the MariaDB Docker image, that's not a problem. But you are getting database is uninitialized and password option is not specified, right? So you need to specify one of the parameters when we are trying to create a deployment, right? So this is why I think we come across a problem, and that is the reason our pods are not able to run successfully. Okay, so let's try to fix this problem. Before that, I would try to describe the pod once again. So these are the things which is very important. I know the reason crash loop back off, the pod is in the terminated status, but you can also look at the exit code. So exit code is not 0. So 0 means successful, but exit code once is a generic code. I do not know what does it mean, but we can always troubleshoot this, right? So now you can again see the status of the pod, which is nothing but the error or crash loop back off. You can see that the status remains the same, and you can also see that this particular pod is trying to get restart and how many times these particular pods are getting restarted, right? This pod is trying to restart, has already tried to start 6 times. This is 5 times and this is 5 times, okay? What I'm going to do is, let's try to fix this particular problem. Okay? I will say kubectl, I will say set, and I'm trying to basically set an environment variable, right? So if I do not know how does it look like, I can also make a use of h minus h, and I will pipe it to less. So this is how it is, how I can basically describe my environment variables. So you will get some kind of examples as well, right? So if you really wanted to import the environment variable from a secret, this is an example. If you want to import an environment variable from the config map, this is an example of that. And similarly, you can see other things as well, right? So for example, if you are trying to set the environment defined, so there are various examples which you can basically make a use of, right? So let me try to scroll a little up. This is just for the illustrative purposes. I'm taking help. So now I will be basically setting some of the environment variables. Let's try to do that. Set, I will say environment, I will say deployment, set environment, and I will say So I think we have gotten an error. If you remember, we did not really specify the environment variables or MariaDB root password. So if we do that, we have done that. So now you can see that our one container is running and one container is running. Now the every container is running. So as soon as I am able to set my environment variable, for example, because I have not really specified my environment variable, which is nothing but MariaDB root password, and therefore my pod was not getting started, right? It was not in a running state, and that is the problem we have. So we first was trying to describe that particular pod, and then we come across an error code. Error code was 1. And the second thing which we did is we are trying to go into the logs of that particular pods that basically help us out, and it was giving us a warning, right? We have not really specified environment variables. So now we are trying to fix that particular problem by setting the environment variables. As soon as I set the environment variables, you can see that my status of the pods are getting refreshed, and now you can see that my pods are running effectively and successfully. There is no problem with respect to that. And now you can see that all the terminated or crash pods are getting replaced with some other pods, right? As soon as this particular problem is getting fixed, the pods which are crashed are basically getting replaced by the new pods, and those particular pods are in the running status, right? So this is how we troubleshoot our applications, right? So always remember this particular thing. So now I think we have come to the point where we are getting started with the service demonstration. So before I try to give a practical demonstration of the service, how does the Kubernetes service look like? So there are certain things which we really wanted to understand. So let me go back to my GitHub repository. If I go to Kubernetes, you can see this is my readme file. So I'm keeping all the commands which I am basically making the use of in my demonstration in my GitHub repository, and you can go to this particular GitHub public repository to refer these commands which I'm using. Okay. So what I'm saying here is, so we have looked at understanding service demo, right? So these are the commands which we are going to look at. So before that, let's look at some of the examples. Okay. -o wide. So I'm basically looking at the IP address. So hopefully you are able to see these are the IP addresses. So these are the IP addresses which are getting allocated to my pods, right? You can see 10.244.15 and similarly 14, similarly 16. So these are the IP addresses which are getting allocated to my pods, right? So every pod has got a different IP address. Okay. If I go back to my image, so here what I'm saying is, now there are two things, right? So in the left hand side, you can see that these are different nodes, right? These are different nodes. So I will say N1, I will say N2, I will say N3, and I will say N4. Okay. But in our case, you know that we are basically running a single node Kubernetes environment, that is nothing but the minikube. So in our case, of course, it is a single node. But in the realistic example, you might have different nodes, and in different nodes, you might have number of the pods running in one particular node, right? So these are the nodes and these are the pods P1, P2, P3, and P4. So I will say 10.88.0.16. Okay. So these are the IP address. So you can see P1 has got this IP address, P2 has got this IP address. Now what I'm saying is, so there is an external network. You can see that this is the external network with the help of which all the nodes are connected, right? So you can see, you can call this particular network as a node network or the external network. The second network, which is, you can see, so this is the second network. You can also call it as internal network or cluster network, right? So for example, I have a single node Kubernetes cluster, but if let's say in my Kubernetes cluster, if I have two nodes, N1 and N2, so these particular nodes, so N1 and N2, so these particular nodes will be connected with the help of my cluster network, what I call it as cluster network. And this is an example of internal network. At the same time, I will say, so my node 1 will have a pod P1 and P2, and at the same time my node 2 will be having a pod P3 and P4. Okay, P3 and P4. So the pods P1 and P2, so these pods P1 and P2 will be connected with the help of what we call it as pod network. Okay, and similarly my pod P3 and P4, right? P3 and P4 will be connected again by my pod network. Okay. So let me try to clear my screen a bit. So I'm just trying to make you understand how does the communication happens. So this is nothing but this is the pod network. Okay, let's assume that this is all the pods are in one particular node, and this they are connected by the pods network. Okay, so this is a pod network, this is the cluster network, and this is the external network. When my user is basically trying to access any kind of the application, so my application is deployed here, right? And this my application is deployed here. So, and this is a service. Since user is basically coming from the external world, he will not be able to access the application running in my deployment, which is this one, right? In my pod network. So what user can do is user will basically go to the DNS, okay? And then DNS, in front of the DNS, this particular request will be go to load balancer. Okay, load balancer. And so load balancer, now this particular request will be getting forwarded to my nodes. Okay, so this is my node, this is my node, this is my node, and this is my node. Okay, and from the nodes the request will be getting forwarded to my service, right? My service. And from this particular node port my request will be getting forwarded to my pods. Okay, this one, this one, this one. So this is how the communication is happening, right? So when we basically make a use of cluster IP, so cluster IP, you will external users will not be able to connect to your cluster or will not be able to connect to your application, because cluster IP you can only grant access to the cluster itself. But when I try to change, so service will have two types. Okay, so cluster IP will only be available for the cluster itself. For the external world you have to make it as a node port. So now if I make it as a node port, now you can see that I am basically opening some of the default ports, which is of 32,000 as a range, will be getting open to the external users. And in front of our nodes we will be coupling with our load balancer, right? And load balancer will be getting the external IP assigned to it, external IP, and this particular external IP will be mapped to our DNS, right? Which will be routing services from the user interface. So this is how the communication is happening. Okay, so I know it is little bit of the detail when we try to look at how does the service works, but this is how it is, right? So let's try to look at the practical demonstration of the service. So kubectl, you can see that there are certain pods which are running. So now what I'm going to do next is kubectl, I will create one more deployment. I will say create, I will say deployment, I will say nginx svc, I will be using image as an nginx. Now you can see that my deployment is created, kubectl get pods. So now you can see that for our deployment there is only one particular pod at this point in time. So now we are going to scale the deployment. Scale, I would say scale, I will say deployment, I will say nginx svc, I will say replicas. So now you can see that we have successfully scaled our deployment, right? So if I try to clear my screen and try to get pods, now you can see that there are 7 pods running. So last 4 pods is what we have created, nginx svc. So this is the deployment name, which has got 4 pods, p1, p2, p3, p4. Okay, so we have got 4 pods. Now what I'm going to do is kubectl, I will try to get svc. Okay, so now you can see that as of now there is no service running. As of now you can see that there is only one particular service. So this is a service which is running, this is the default service. I have not created this particular service for our deployment, right? This is the default service, right? So I am going to expose our deployment. I am going to create a service for my deployment, which is nginx svc. I will say deployment. I will say nginx svc. And because we are basically referencing nginx as an image, let's call the port number as 80. So now you can see that we have created a service. If I say kubectl get svc, so svc is a short name for service. So now you can see that there are two services, right? So this is a default service which I have not created, okay? And this is a service which I have created just now for our deployment, which is nothing but nginx svc. So for this particular service, we have for this particular deployment, we have created a service. One more thing, kubectl get endpoints. So we have got 4 pods, so we should be able to see 4 IP addresses correspond to that, okay? Hopefully you are able to see that these are the IP addresses which are getting assigned to the pods itself. So we have got 4 endpoints, okay? So now what I'm going to do is one more time, kubectl get svc. I think sometime before I was telling you about, okay, the service can be of two types, okay? One is cluster IP and one is node port. And if we have a Kubernetes distribution, let's say like EKS or AKS or GKE, we have a third type of the service, which is the load balancer. So cluster IP, when the service is by default cluster IP, we will only be able to establish a connection to the pods from the cluster itself. External user will not be able to make a connection when the service is cluster IP. When we are trying to make the service as a node port, for this we will be seeing the practical demo, okay? So don't worry about that. And for the load balancer, because I am basically using minikube cluster, I will not be able to show you the demo of the load balancer as of now. So since it is a cluster IP, if I try to curl, let's say I have got endpoint addresses, I will say 10.244.0.17, okay, /80. So I am basically trying to curl, I am basically trying to do a curl to this particular endpoint, right? So I am in my Ubuntu machine, right? I am not in this cluster where the pods are getting deployed, right? Just understand this. I am from the outside. My host name, my IP address or my host name is different. It's not a part of the minikube cluster. So you should understand that. And because my service is type of that a cluster IP, only the people who are a part of the Kubernetes cluster should be able to connect to this particular pods or the endpoints. And therefore, I have not got a result. I haven't got a result of curl command, right? No output. So if I terminate this command, what I am going to do next is I will say minikube ssh. So now I am getting into the Kubernetes cluster, okay? I have gotten into the Kubernetes cluster. So if I try to do curl now, 10.244.0.17, if I try to curl, now you can see I've gotten the output of the curl, right? Now you can see that I have gotten the output of the curl command because now I am inside my Kubernetes cluster, right? Inside my minikube cluster. And therefore connection is established successfully. Okay, so now I can exit from my minikube cluster. I will clear my screen. So what I'm going to do next is I'm basically trying to change I will be changing my service type, okay? So one more thing I want to show you before I make the changes. You can see this particular minikube. So this is the IP address which is getting allocated to my Kubernetes cluster, right? So now I am going to change the IP address of my service. Okay, how will I do that? kubectl, I will say edit, I will say svc nginx svc. Okay, I will just say edit. I need to scroll a bit down. Okay, so here so now if I go here, okay, so now you can see that the type of the service is nothing but the cluster IP. So I will be making it to the node port. Okay, that's it. So this is the change I really wanted to make. So I will just escape wq. If I try to kubectl get svc, so now you can see that my type of the service from the cluster IP is getting changed to the node port, right? And I'm also able to see that when I try to expose my service as a part of the node port service, I also got one particular port, right? So now this particular port is getting opened at the side of my node. Okay, just understand that at this point in time. So if I try to curl and I already know my minikube IP 192.168.49.2. And if I say 32.329, so now you can see that whatever the port that is being exposed by my node, I'm able to establish connection on that particular port, right? If I clear my screen and again try to, so you can see, so this is my port, right? You can see that this is my port. This is my port. And if I try to do the curl from my local machine is nothing but the Ubuntu machine. And if I try to run this particular command, if I try to curl to my minikube IP address using this particular port, which is being exposed by my service, and I am able to get the output of my curl, right? This is how we are exposing our service to the external user. And I have already explained the entire workflow in my, whatever the image that I have storing in my GitHub repository, right? This is the demonstration which we have completed for the service. Now we are going next for the another demonstration, which is persistent volume demonstration. So if I go to GitHub repository, all the commands which we have used in my service demonstration, you should be able to find in my GitHub repository. That's not a problem. So now I will be getting to my volumes demonstration, right? So before I go there, just wanted to discuss a little bit of the stuff here. So when we are talking about volumes, right? So for example, if I created one particular pod, and as I said that, in most of the cases, one particular pod will run only one container, and this particular container will be mounted to the temporary drives, right? Will be mounted to the temporary drives. So we know the containers and pods are ephemeral in nature. So they are ephemeral in nature. So once this particular pod just a second, ephemeral in nature, right? So once this particular pod is getting terminated or container is getting terminated, whatever data I have kept in this particular drive which is mounted to this particular container, that data will be gone, right? So how will I persist this particular data which I stored in this particular drive of the container, right? we will be doing with the help of the volumes, right? So volumes is nothing but one of the storage class, right? So now I said that, so pod is nothing but the collection of some of the resources, right? So your pod can be bundled with, it might have one container, it might have two containers. Your pod can also be bundled with your volumes, right? Volumes, and therefore the pod as an entity is little bit different as compared to the containers, because your pod as an entity can be bundled with your volumes as well, which is nothing but the storage class. Okay, so what happens is, you can see that this is the pod which is bundled with PVC. PVC is nothing but persistent volume claim. So in persistent volume claim, which we will be basically describing whether it is read only or whether it is read write, or how many of the GB of the space should be getting allocated to this particular storage class, right? So when I define my persistent volume claim, automatically, so let's assume that this Kubernetes distribution is EKS, okay? Elastic Kubernetes Services on AWS, okay? So now what happens is, since we have already defined persistent volume claim, which defines we should be having a read and write type of the persistent volume claim and 10 GB of the memory, it will automatically start looking at the default storage, okay? The storage class which is available. So for the AWS, the storage class which will be available by default to us will be Elastic Block Storage, right? EBS. So automatically my PVC will be getting bundled to the storage class, which is the default storage class, and that should be available in your environment, right? Automatically be getting available. The second way of doing it is, you can also tie this particular PVC manually to the persistent volume, but in that particular case there might be certain limitations. So just understand that your pod is bundled with PVC, which can define certain types of attributes, like whether you want read only or read write, or 10 GB of the memory of the space allocation has to be done on your storage class. Automatically storage, the default storage type which is available in your PV as a storage class will be getting bundled to your pod, right? So this is very, very important. So this is how you basically try to persist your data, right? So it will be getting little more clear. So currently I will be giving you an example of the local storage class. I will not be going into the storage class which are being provided by your cloud service providers. So let's look into that. So demo. Okay, so sorry about that. Yes, so I'm going back to my machine. Let me clear my screen. So let's try to do that. I know the concepts which were there in Kubernetes, it's little bit, I would say, comprehensive, and it requires little bit of the understanding before we can really forge a good understanding about those concepts. But yes, I'm trying my level best to give you that understanding from my experience. So yeah, talk about the demo. What I'm going to do next now, so let me go back to my GitHub repository and just trying to find one particular file. I will say more volumes. So I'm just copying the contents of this particular file, and I will try to, so let's say vi, I will call it as more vol.yaml. okay, I will go into the insert mode. This is not what I want. So I think I tried to copy the entire content. That doesn't happen. So let's try to copy again. Yes, this time it has happened. I will go into the escape mode, WQ. Okay, if I try to cat more vol, I think it should be giving me the YAML content. So before I get into the nitty-gritties of my demonstration, I just wanted to explain you, I think, the good way of doing that is, if I do less more volume. Okay. So the first thing first is, guys, so the first thing is you can see the kind, right? So this is the pod as a resource in my Kubernetes distribution. I've given the name of the pod, that is nothing but the more vol. And in the specs, I can see that I have defined containers, right? The first container is CentOS 1, and I'm using CentOS 7 as an image. And then I'm also executing these commands, right? Also executing these commands. And I have also mounted volumes. You can also see the volume mounts, which is nothing but CentOS 1. And similarly, you can see the volume mount for my second container, which is CentOS 2. Okay. And I'm also executing certain commands here. The important thing is I'm trying to mount volume paths, right? I'm trying to mount paths. So for one of the container, it is a CentOS 1. And for the second container, it is CentOS 2. And what I'm going to do is I'm trying to create a test file here, right? Test.txt file here. And because, so one more thing. So for example, now both of these particular paths refer to the same thing or mounted to the same directory. So what I'm saying is the file which I'm going to create here should be getting reflected here in the CentOS 2 directory as well, right? So let me try to explain once again. What I'm saying is, so you can see that I have tried to define two paths, right? Mount paths, right? The first is CentOS 1. The second one is CentOS 2. Okay. So both these particular paths are basically referencing to the same path, right? Both are basically referencing to the same paths. Just try to understand that. So just understand that. So since both the paths are referencing to this particular path, let's understand it is a root directory. So if I try to create one particular test.txt file here, it should always be present in here as well, test.txt. Okay. So if I try to clear my screen and try to go here, okay, so let's look at the demonstration of that. I think that will make it a little more clear. So the second thing I'm saying is kubectl. I will say apply. I will say -f. I am using the declarative way. We have already had a discussion about that. So now you can see that if I say kubectl, now you can see that I have got one more pod which has gotten created. So it's still trying to create that. Now you can see that both 2 out of 2 containers are ready, right? So in this particular pod, right? So I already made you understand that, one particular pod normally have one container. So this is the most important arrangement, right? So normally this is the architecture, right? Only one particular pod should have one container. But now in our architecture, if you see like this, here it says 0 out of the 2 containers are ready, right? So I have created a pod which is named as more volume. So this is the name of the pod. Okay. In this particular pod, I have got 2 containers. Okay. 2 containers. So there are 2 containers, right? So though this particular arrangement is little less used. Mostly we see this kind of the arrangement always, but this is a possibility. Okay. So now what I'm saying here is, so let's try to describe this particular pod, whatever we have, right? So kube describes pod more vols. Okay. Yes, we are able to describe our pods, right? So when I try to describe this particular pod, what I really wanted to make you understand is you can also see in the events that we have created a container 1 which is CentOS 1, and then we have also created a container 2 which is already present, right? So for the first container, the image is getting pulled to my local machine, and for the second container, I already have that particular image in my local system, and therefore it needs not to be pulled from the Docker Hub repository. Okay. These are the two things which are important, and if I try to scroll up a bit, just a second. So here you can see again the container 1. This is the first container. Again, it is using CentOS 1 as a Docker image. The state is running, and you can also see this is the second container, right? So I just wanted to demonstrate that there are two containers within our pod which we have created, right? So if I clear my screen, so now what I'm going to do is kubectl get pods. I'm trying to exec into one of the pods, right? I will say -it, and more wall, okay, more wall, and I will specify the container CentOS 1, and I will say sh or bash. Okay. So I am into the CentOS 1 as a container. If I try host name, you can see more wall. So this is my pod more wall. So if I say this is the host directory, so now what I'm going to do is, if I try to do ls, now let's go into the directory cd CentOS 1, right? So what I'm going to do here is, this is my present working directory. I'm basically going to create one particular file, test.txt, right? So do you understand what I did? So what I did is, in my container, which is nothing but CentOS 1, okay, I logged into this particular container. I go into this particular directory CentOS 1, and I try to create one particular file which is nothing but test.txt. Okay, so now both my containers are mounted to the same path. What I'm saying is, when I go to this particular directory CentOS 2, will I be able to find this particular file here or not? Because both are basically mounted to the same place, right? Let's do that. So kubectl, I will say kubectl exec -it more wall, okay. -c CentOS okay. So present working directory is a root directory. I will say CentOS 2. Okay. Now if I try to do ls, can you see here ls -l? Can you see that there is a file which is nothing but test.txt, right? So I've created this particular file in the CentOS 1, but because both the mount paths are basically pointing towards the same thing, I have got this particular test.txt file because I have tried to create a persistent storage, right? So this is what I really wanted to demonstrate in this particular demonstration. Hope it makes a little sense. So let me try to exit. Let me try to exit from this and Control L. Okay, I think I am basically moving towards my last demonstration for this particular course itself. And if I go here, so we have successfully concluded our persistent volume demonstration, and this is the last demo for us in this particular course. Hopefully it will make sense, right? So again, just wanted to go back to my repository. All the commands which I am basically making the use of are basically available in my GitHub repository. You can go there and try if you are interested, right? So I've kept all the commands which I am using in all the demos are here, and you can basically make a use of this GitHub repository as an additional resource for yourself. So config maps, right? So already looked at this particular thing. So config maps are something, right? What is config maps? Config maps are basically used to store so config maps are something which is basically responsible for storing site specific information, right? Site specific information, right? When we say that this one, or not information, I can also say configuration, right? Site specific configuration, right? So if you have any of the application related config files, we can basically make a use of config map. So without a further ado, let me go back to my machine and let's try to conclude our discussion. So just give me a second. kubectl. So all these particular demos are running. Let me try to kubectl delete. So I will say mydb. Let's try to clear some kind of the resource utilization for our minikube cluster and try to go forward with that. Okay, so we are basically looking at config maps demonstration, right? So kubectl, I'm going to create a deployment and I will say mydb. This time I'm going to make a use of the image, which is nothing but, I will say mydb, and image should be MySQL, okay? And I will say replicas is equal to 3, okay? If I say kubectl get pods container creating, and I will say container creating, I will say container creating, and I will say, so you can see that we are basically getting the status as container is getting created, and in some time we will be getting the error. So can you see here, we are basically getting an error, right? We are basically getting the error which we have already looked at, crash loop back off. And previously we also remember that we haven't really passed some of the parameters like my root password or something of that sort, which resulted in a consequence that we were not able to create the pod successfully, right? So similar kind of the stuff is happening here as well, right? Now how we can really clear this particular stuff, let's try to do that. So if I so what I'm going to next is, let me clear my screen. What I'm going to next is, I'm going to create a config map now, right? So let's do that. kubectl create, I will say config map, my new mydb vars, okay, mydb vars, and I will say from literal, okay, is equal to, I will say my SQL password is equal to password. So I'm basically going to create a config map. Let's do that. Okay, there is some issue with respect to so my config map is created, kubectl, I will say kubectl get cm. So now you can see that I have created my config map, and you can see that config map here. The name of my config map is my db vars. I'm not able to see the content of this particular this particular MyDB where's config map resource, right? How will I do that? First, let me delete this. Okay, so how will I do that? kubectl, I will say kubectl, I will say describe, I will say config map, and the name is my db vars. I think we are reaching the end of the demo and something is happening to me. kubectl. So can you see here, now I am able to see the contents of my config map, but it will definitely not be showing, so for example, so this is the parameters, right? So this is what I have kept. So this is nothing but the key value pair. I will say the key value pair. You can say key value pair. And similarly, you can also use secrets, right? Secrets for key value pairs, right? So what will happen is it will basically store the key value pairs and it will be base 64 encoded, right? So that is the only difference between the config maps and the secrets, right? Base 64 encoded. So secrets are not secured. Whatever we are storing in the secrets is base 64 encoded. They are not encrypted. So for that reason, secrets are not secured. And that is the only difference, right? So config maps are not base 64 encoded. Secrets are base 64 encoded, right? So let's try to clear that particular stuff. And so we have created a config map, and now we are trying to make a use of the config map. If I say kubectl, so we have also tried to run this particular command previously. So this time we are trying to set the environment variables from the config file. From is equal to, I will say cm, I will say my new MyDB vars, and to my deployment, that is MyDB. So you can see that if I say kubectl get pods, and that is something I really wanted to avoid. So kubectl get pm MyDB vars kubectl get deployments. So I need to check what has gone wrong. So let's try to check, so I will say kubectl set environment variable. I will say from is equal to config map, and I will say my db vars, and I'm basically doing for my deployment, which is nothing but my db. Okay, so if I do kubectl get pods, okay, I think there is some kind of the error. So what we can do is let's try to kubectl get deploy. This is my deployment. So kubectl create. Let's try to create one more deployment. I will create a deployment. This time we will say my new db. I will be making the use of the image, which is nothing but MariaDB. okay, and replicas is equal to 3. This deployment is getting created. So if I say kubectl, so now you can see what I can do is I can just delete my previous deployment. Delete deploy my db. That is deleted. So now you can see that similar kind of the error is happening to my new deployment, and we are basically making the use of MariaDB image. What we are going to do next is, and we have already troubleshooted that we have not really passed some of the environment variables, and we will be passing those environment variables with the help of the config map. So let's create the config map. Create, I will say config map, okay, and this time I will say my new db vars, okay, from, I will say from literal is equal to before I do that, I just wanted to do one more thing. So for example, kubectl, if I say logs, if I say my new db, let's say L, okay, so now we can run the command which we were running previously. So I will say from literal, I will say MariaDB MariaDB root password, and at the same time I will be giving some value, let's say secret. That's it. So I can also list this kubectl get config map. You can see that I have created config map my new db vars, okay. So let's try to look at the values of the config map. So how will I do that? Kubectl, I will say describe, I will say config map my new db vars. Now you can see that this is the key value pair which we are storing in the config map. Let's try to make a use of this particular config map. So cube. So again, the status is crashed loop back off. Let's try to correct that. I will say kubectl, I will say set environment, and this time I am basically going to make a use of from, and I will be using config map, okay, and config map name is my new db vars, okay, and for my deployment name is my new db. So can you see that here, if I do again, you can see that now all the pods are running as expected, right? So you can see that as long as I set the environment variable, the pods which were existing, it is getting terminated, because anyways here you can see it is crash loop back off, and the new pods are getting started, right? New pods are getting started. So the older pods are getting terminated, and the newer pods are getting instantiated as a result of setting environment variables, and we have set the environment variables with the help of config map. So this is an example of the config maps, and this is what I really wanted to cover in our demonstration. So let's do that. And so we have covered all the different things, right, in our demo, right? So hopefully you like it, and please share, subscribe, like, and share the feedback. How do you like it? So we looked at 4 demonstrations here, and I have also shared my GitHub repository with you guys, so you can also refer any kind of the command which we basically made a use of in our demonstration. You can refer my GitHub repository for that matter, and just give me a feedback, share, comment, like, and subscribe. Thank you so much.